Every living thing is exposed to radiation all the time quite naturally. Background radiation is about the radiation dose a typical person would receive. Alpha, beta and gamma all cause ionisation of atoms as they pass near them. As we'll see in Lesson 7, unwanted ionisations in our cells can upset our cell chemistry and may cause health problems. So other forms of ionising radiation, for example X-rays, also get included when calculating background dose. Radioactive isotopes have always been part of the Earth. The Sun and planets were formed about 4.5 billion years ago from the dust and gases of long dead stars. The supernovas that ended these stars' lives created the incredibly high temperatures and pressures needed for heavy nuclei to be fused from lighter particles like protons. We've already met uranium, radium and polonium, but there are less exotic elements like potassium that have natural radioactive isotopes as well as the stable ones we're used to. Radioactive isotopes in the rocks and soil around us produce alpha, beta and gamma radiation, but the only form that can really hit people is gamma. An exception to this is naturally occurring radon, which is a gas, and so we can breathe it in. The alpha particles released by the radon gas can increase the risk of lung cancer. Different parts of the UK have different radon levels, so there are regulations and precautions to control our exposure to radon. Plants are mostly reorganised carbon dioxide, with very small amounts of minerals from the soil they grow in. Some of the minerals have naturally radioactive isotopes. Animals eat plants, and we eat plants and animals, so we're made from very small quantities of radioactive isotopes too. One of the most important of these is potassium-40, which is a high-energy beta and gamma emitter. We absorb about 3,000 beta and gammas per second from potassium-40 in our body. We also get bombarded by cosmic rays. Fast-moving protons and other nuclei from deep space create a shower of exotic particles when they collide with our atmosphere. These cosmic rays are a form of ionising radiation, and so get added to our background dose. If you live at high altitude or take lots of flights, you're exposed to more cosmic rays. If you have a medical procedure, like an X-ray, this is also added to the background dose, but these are averaged across the population rather than tracked for each person. Other human activity, like nuclear weapons testing, nuclear accidents and nuclear power plants, add almost nothing to background radiation.